All right, here we go. I love this question. This is one of my favorite questions. Question number 22. I nicknamed it the Jared question. If you guys know who Jared Shriver is, I still make fun of him. He's a good kid, but actually he's not a kid anymore. I think he's married now. Anyway, so you've got a monkey. I always name mine Jared. And we've got a monkey. He's been given some force, and he's going on an jumping line. So let's start with what we know. This is my setup. Jared, my monkey, is going on a sled going up an incline. The incline has 25 degrees. So we've got an initial velocity of 4 meters per second. We're going to say a final velocity of 0 meters per second because it's coming to a stop. We know the mass of the sled and the monkey is 20 kilograms. Okay? The coefficient of kinetic friction is 0.2, and they want to know the distance it goes. So, let's start with a simple equation. We've got a velocity, so we're going to say the change in kinetic energy is equal to work, which is equal to force times distance. Now the good news is the change in kinetic energy, we can sit there and say minus 1/2 mv squared to start with of our initial, because our final is 0. We can skip over work because we're going to act like it doesn't exist. The force times the distance. Now this is what's slowing us down. So force times distance, what are my forces? If I'm going up this hill like this, the force going this way is force due to kinetic friction and the force due to gravity in the x direction. Both of those combined are fighting against my distance that I'm going. So 1/2, mass is 20, velocity is 4. I'm going to go ahead and answer that left side because, well, frankly, I don't like it and I want to solve it. So 4 times 4 is 16. Really, 4 times 4 is 16. 16 times 10 is 160. Now, that's the easy part, right? We're still looking for this distance. Force due to kinetic friction. Well, okay, the force due to kinetic friction is coefficient times of kinetic friction times our F of n plus F of g of x. It's force due to gravity times a cosine. Actually, in this case, sine of theta. And if you guys don't remember that, how to solve that, straight down is f of g, f of g of y, f of g of x. This is the adjacent leg, so it is sine. Cosine, good gravy. And this is sine, because it's the opposite from my angle. So again, all of this times distance. This one's going to get long and tedious because you still have the 160 equals the coefficient of friction times F of n. Well, F of n is really F of g of y because it's up and down plus F of g sine of theta times the distance. Wow, my handwriting's horrible with this big marker. So last but not least, 160 equals coefficient of kinetic friction, F of g, I'm going to write it out, mass times gravity, in this case, times cosine of the theta, plus mass times gravity times sine of theta times distance. Super long way to write this out, but it's step 1, step 2, step 3. So now we have 160 equals coefficient of friction is 0.2 times the mass, which we said was 20, times gravity is 9.81, times the cosine, in this case the angle is 25. plus mass again, 20 times 9.81 times the sine of 25. All of that times distance. Again, this is one of the reasons why you write everything out, but let's take a look and see what we can clear up. So let's do this first part first. 0.2 times 20 times 9.81 times the cosine of 25. Okay? 38.895 plus 20 times 9.81 times the sine of 25 is negative 25.96. That's disturbing. Awesome. Let's do this again. Rule number one, if you're starting any physics experiments, you should probably check, make certain your calculator is in degree mode. Let's double check that first one. Whew. Not too far off, 35.56 plus 20 times 9.81 times sine of 25. $82.91. Yes? Times distance. That looks a little high. Hopefully I haven't messed up more. For all of you smart people, hopefully you're looking at this going, wait a minute, he messed up there. So, hopefully we've got that part down. So let's add these two together plus, that, enter. So we have 160 equals 118.5 times distance. Divided over. Whew, 1.35 equals your distance. That is one of the longest problems ever. However, if you look at it, start with the simplest version of what we could have done. Started with a work equation. Kinetic energy equals work equals force times distance. We know it's coming to a stop. That's why we canceled this half off. 0 minus the kinetic energy we have, force times distance. The only forces slowing us down was kinetic friction and gravity in the x direction. So we said, what was friction? What is f of g of x? And continue on. And step by step, it will work out. The book does show you another equation to do this. I like this version only because step 1, step 2, step 3. As long as you start with the premise, you can figure it out and go, okay, what does each one mean? Okay? Good luck. Hopefully you have questions. If you have questions, ask Ms. Heinemann when she returns or email me. That's either one.